This next section is very short. It's just on formal charge. It's 2 slides long. Formal charge is related to resonance in a way, but it's a distinctly different thing. So resonance is when all the other things are the same. So like you have all oxygens around it, and you have a double bond rotating, or all fluorines or anything like this. Formal charge is when you have stuff and you need to know which one's going to hold the extra electrons, or which one's not going to hold the extra electron. And basically, again, there's a good section in your book. It's like 2 paragraphs that really explains this. But basically, it's telling you which atoms should have the charges and which atoms shouldn't have the charge. And it's assuming that they all have the same electronegativity. So they don't really, but it's an assumption that we found works experimentally. So there is like a little equation. So if you're trying to find your formal charge, it's going to equal I'm going to make a big box here, your valence electrons. I have to make this bigger. Minus your non-bonding electrons plus half of your bonding electrons. And then I'm going to have to close this off, and I'll make it bigger so it all fits. And when you do formal charge, you do this for each element in the compound and see which one gives you the lowest, well, I shouldn't say lowest numbers, the numbers closest to 0. So neutral in this sense is good. So let me just make this look a little different. Doesn't like me, so we'll underline. Alright, so just here's an example of one where I'm going to show you how to actually do the formal charge, and then I'll show you on the next slide. Okay, so once you have the formal charges, how do you use them? So here is cyanide, and we want to just do the formal charge for carbon and the formal charge for nitrogen. And this -1 is just for the whole compound here, so that's all it's for. So let's do formal charge of carbon first. And let's make it so you can actually see. Okay, so we're going to say formal charge equals, and again, we have to do valence electrons. You find your valence electrons by looking it up on your periodic table. So carbon is in the 4th tall column, so it has 2 s electrons in its valence, 2 p electrons in its valence, which means this guy has a whopping 4 valence electrons. And we're going to do minus our non-bonding electrons. Non-bonding electrons are just our dots. So we have 2 plus half of our bonding electrons. So you can think of bonding electrons one of 2 ways. The bonding electrons count all the electrons that are in the bond. So we have a triple bond here, that's 6 electrons. An easier way to think about it, I think, is just count how, like if you have a single bond, that's you get 1 bonding electron. If you have a double bond, you get 2, because you get 2 of the 4. If you have a triple bond, you get 3, because you get 3 of the 6. But basically, when we say half of the bonding electrons, we mean half of this whole big section in here. So since there's 6 total, it's like if you get a divorce, you cut down the middle. So carbon gets 3. And you just do your calculations. 4 minus 5. This guy's -1. And then we do formal charge of nitrogen. And again, formal charge equals, look up nitrogen, and nitrogen is 5 valence electrons, minus, again, look for his lone pairs. He has 2 dots, so he's that. He's also in the triple bond, so he gets 3. And he has a formal charge of 0. So that's how you actually calculate formal charge. The next slide, we're going to look at how do we use it. So when we talk about the most stable Lewis structure, again, it's the smallest formal charge. So again, we're saying who's the closest to 0. And again, if you have to, you probably want to highlight this, if you have to have a charge, the most negative charge goes on the most electronegative. So if you have to, whoever likes electrons gets to keep them. You do want to keep in mind these are not actual charges. This is just a way to figure out, okay, like down here, should this have the triple bond? Should there be 2 double bonds? Should this one have the triple bond? So these numbers right here are the formal charges. They are already calculated for you. On a test, this would not happen. On the AP test, this would not happen. But just to help you, I'm not going to spend 20 minutes doing 9 formal charges. So what you look at once you have your formal charges for all your possibilities is you say, okay, who's definitely out? And then you should probably cross this guy out, because you can see there's no reason to have a -2 and a +1 when you don't have to. They're larger numbers away from 0, and that's not what we want. So what it comes down to is you have to pick either the guy with the 2 double bonds or the guy with the 1 triple bond. So what you say is, okay, who should have the charge? Who is more electronegative? And what happens is when you look it up on your periodic table, nitrogen is more electronegative, so he should have the charge. So I'll just type that out. Nitrogen is more electronegative than sulfur, so he should have the negative charge. And that negative should stay with nitrogen. Again, is this a major tenet of your whole life, and that if you don't understand this, you'll never make it in the real world? No, but does it show an understanding of why certain things happen? Yes. Again, you'll practice these. There's a good section in your book, and you need to make sure that you understand what formal charge is.